I have a video discuss the derivative of these basic functions by using derivatives definition, by using a definition of derivatives. Okay, if you're interested, you can go find it. Now, I'm talking about these basic functions, get their derivatives by using the definition. Now, today, I'm talking about using the definition of derivatives to find the derivative of some simple functions. These are not basic functions, but rather specific functions, simple functions, just to practice using the definition of derivative to find the derivative. Okay, let me do one by one. Okay, now when I change the pen, do you see clearly? The derivative of f with respect to x is equal to the limit h goes to 0, f of x plus h, f of x plus h minus f of x divided by h, right? That's the definition. So I apply this definition to my particular function. That is equal to the limit h goes to 0. Here h, there will be 3x plus h square minus 2x plus h plus 1 and minus 3x square plus 2x minus 1, right? Simply executing the algebra. Then this is equal to the limit h goes to 0. This will be 3x squared, right? Plus 6xh plus 3h squared minus 2x minus 2h plus 1 minus 3x squared plus 2x minus 1. Let me see where the cancellation. This is cancelled with that one, right? Yes. 2x cancel with 2x. 1 cancel with 1. Then left over the limit h goes to 0 is h. H is a common factor. You have 6x plus 3h minus 2, right? That's it. Then cancel with the h. Take the limit as h goes to 0. Left over is 6x minus 2. So that is my derivative of this function. Okay. So I find the derivative of this f of x with respect to x using the definition. There's no formula. Okay, then let's do the second one. This one. F derivative with respect to x is equal to the limit h goes to 0 over h 2 sine 3x plus h, right, minus 2 sine 3x. Okay, that's simply using definition of a derivative. Now then this one is equal to the limit h goes to 0 is h, and here you have a 2 sine 3x plus 3h, right? Minus 2 sine 3x. Then using the trigonometric, the sine a plus b, that is h, then 2, this will be sine 3x cosine sine 3x cosine 3h plus 2, bring the 2 here, sine 3h and cosine 3x minus 2 sine 3x. Okay, then this one equal to the limit h goes to 0. You have h. Sine 3x are a common factor, right? So 2 sine 3x is common, so you have a cosine 3h minus 1 plus 2 sine 3h cosine 3x. Okay, then here I split this fraction into 2, so this will be equal to h here, 2 sine 3x times cosine 3h minus 1 and plus h here, 2 sine 3h cosine 3x. Yeah. Well, do you know the basic limit, which is the limit theta goes to 0, sine theta over theta is equal to 1, right? Well, I hope you know this one. Now, we are not using L'Hopital's rule. Of course, we don't know those stuff before the definition of a derivative. We are using unicircle, right? This is 1, the unicircle. This is theta, and this will be sine theta, right? This will be tangent theta. This will be theta, because the radius is equal to 1. The arc length is equal to angle in radian. Okay, so sine x and sine theta and the theta and the tangent theta, these are 3 parts like this, right? Like this. This is the longest, this is the shortest, this is the middle. And then we divide by sine x, so this is equal to 1. This is theta over sine theta. This is equal to 1 over cosine, right? Yeah. Now then theta equal to 0. This one is equal to 1. This is 1. So this one must be squeezing into 1. So this limit as theta goes to 0 is 1. That's the basic limit, before we learning the derivatives. So That is the basic limit. Now there's another limit. The limit is that the theta goes to 0, cosine theta minus 1 over theta. That's another one, another basic limit. We can multiply by cosine plus 1, right? Cosine plus 1. And then this, the theta goes to 0. That will be cosine square theta minus 1, right? This will be cosine theta plus 1. Now this one is equal to negative sign, right? Negative sign square theta. So as this one goes to 0, this goes to 0. This one goes to 1. This goes to, therefore denominator is the 2, right? This eventually equal to 0. So this limit is 0. It's 0. This limit is 1. So these are two basic limits before we have a derivative differentiation. Now here I can multiply by 3 here, right? Then this becomes 6. I can multiply by this 3. This becomes 6, right? So this one is equal to 0, as we said before. This is 0, so everything goes to 0. This one goes to 1. As discussed before. So this one goes to what? This one is 1, this is 6. Right? Yeah, 6. Now, so the whole limit, this one goes to 0, this is gone, this is 6. This is cosine 3 theta, cosine 3x. This is cosine 3x. X is nothing to do with h. X is nothing to do with h, therefore this limit is equal to 6. This is equal to 1. This is 6 times cosine 3 theta. So this is my derivative of f of x with respect to x by using definition of a derivative. We didn't use a formula, or we didn't use chain rule, any rule. No formula, nothing but the definition of a derivative. Okay, that is the second one. The third one, this one. Now, the derivative of f of x is equal to the limit h goes to 0. Definition only. This is 3 e to the 2x plus h, right? Minus 3 to the e to the 2x over h. Now, then this one is equal to the limit h goes to 0. H here, this will be 3 e to the 2x times e to the 2h, right? Minus 3 to the e to the 2x. Now I have common factor, 3 e to the 2x. And here is e to the 2h minus 1. No formula, no rule, nothing but definition. Here now, this one equal to This is nothing to do with h, right? There's no h here, so we can bring out nothing to do with h. This is a limit, h goes to 0. What is e? E is this. What is e? E is this, the limit, right? X goes to 0, 1 plus x, 1 over x. That is e. Okay, this is e. So I'm using definition of e. This is a 1 plus h, 1 over h. That is e. E to the 2h minus 1. Then this is equal to 3 e to the 2x. The limit, h goes to 0, h. Now then I can simplify, this one becomes 1 plus h to square, right? Minus 1. Now then we take limit. This one goes well, we cannot take limit, right? Because they infinity. And then we continue. Limit. This one is 1 plus 2h plus h squared minus 1 over h. Now the 1 cancel out. So this is 3 e to the 2x. The limit, h goes to 0. Now h is a common factor. 2 plus h. And cancel out this one, right? As h goes to 0, this is 2. So the result is 6 e to the 2x. So that is my derivative of f with respect to x. 6 e to the 2x. You see, no formula, no chain rule, but the definition of a derivative. Okay, so many simple functions you can use the definition to find the derivative. Well, complicated functions you can do too, but it's very complicated. Okay, thank you for your watching.